Hello guys, it's Josephat. I'm back with another problem, and that is on indices and logarithms, a topic in Form 2. And today I want us to look at different questions on this topic. So first of all, before we start, I need us to look at the rows of indices. There are different methods of how you can solve the indices questions. You can either use the rows of indices, or you can rewrite your question in form of a quadratic equation. And then solve for you to find the unknown values. I'm going to show you both methods, so be attentive. If you have any question, remember to ask. Don't forget to like the video, subscribe to my channel, and let me know what you think about the lesson. So let's start on the rows of indices. We have 3 rows of indices. The first one says that if you have the same base, or if you multiply the same bases, the answer to that question is that you should add the powers. So for example, a to power m times a to power n is equals to a. Where you have multiplication, you add the powers. That is the first row. The second row is that if you divide the same bases, you subtract their powers. So am, or a to power m, divided by a to power n is the same as a to power m minus n. Then if you are multiplying the powers, for example, a to power m into bracket to power n, you just multiply the powers. So your answer here will be a m to power n. We are going to see an example on this, but before that, let's look at a summary of the logarithms. So if you have an expression that is log a of n is equals to m, that expression is what we call logarithmic notation. So at times you'll be finding a question that needs you to change from logarithmic notation to index notation, or index notation to logarithmic notation. We are going to see about that in the next lesson. So when you are, but maybe before we start, let me show you something on this. If you are told to change from logarithmic notation to index notation, you just come and write your expression just like the way you read the expression, that is log to base a of n is equals to m. This here a becomes your base. Log to base a of n is equals to m. Then you make whatever is on the equal side of the side of the equal sign to be your power. Then this becomes your number. So when you are changing from logarithmic notation to index notation, what you do is that you take your base, then your power, you write it on top of the base, then equate it with your number. For example, now if you have log to base a of n is equals to m, and you want to change it to index notation, you just take your a to be the base, so a, then m to be your power, to power m is equals to the number n. So that is how you change from index notation, from logarithmic notation to index notation, and from index notation to logarithmic notation. If you are changing to the other side, you use the same procedure. So let us look at a question from the rows of indices. I like using this book because it has all the KCSE past papers from 1999 to 20. This was from 2017, but you can get the one that has up to 2019. From Form 2, I've chosen a question on indices, that is question 13. That is 81 to power 2x times 27 to power x over 9 to power x is equals to 729. Now, for you to use the rows of indices, you need to, because on the rows of indices, we had the same basis. So for you to solve this question, you've been told to solve for x in the equation. So for you to solve for x, you need to put this number, this number, this number, and this number to be of the same base. So we need to write 81, 27, 9, and 729 to be of the same base. If you look at 81, 27, 9, and 729, they are all multiples of 3. So what you need to do is, you need to write 81 as a base of 3, and for you to get 81, or for you to change 81 to be in a base of 3, you need to use factorization method. So if you take the first 3, 81 divided by 3, it's going to be 27. So 3 will be in 81 27 times. Then the next one is 3, 27 divided by 3, that will be 9. Then the next one is 3, 9 divided by 3, that is 3. So 81 can also be equal to 3 to power 1, 2, 3, 4. 3 to power 4. 81, no, 3 to power 4. That will give you 81. 27 is the second number. You put it to base 3. That will be 3. It will be in 27 9 times, or you can just take your calculator. 27 divided by 3. I'm going to jump where I'm going to use a calculator so that we can be fast. 3 3. So this means it will be 3 to power 1 2 3. 9 3 3. It means that 3 to power 1 2 is equals to 9. 729. 3. 729 divided by 3, that is 243. 243 divided by 3, that is 81. 81 divided by 3, that is 27. 27 divided by 3, that is 9. 3 3. So 729 can be equal to 1 2 3 to power 1 2 3 4 5 6. 3 to power 6. So you replace these numbers with 81, 27, 729, and 9. So for 81, that is 3 to power 4. So it's going to be 3 to power 4 to power, on the question it had 2x. I hope you can see. 3 to power 4 is 81 to power 2x times 27 is 3 to power 3. So 3 to power 3, then it was to power x, over 9 is the same as 3 to power 2. So it's going to be 3 to power 2 to power x. is equals to 729 is the same as 3 to power 6. So 729 can be replaced with 3 to power 6. Now you use the rules of indices where we have a to power mn. We multiply the powers. For example, 3 to power 4 to power 2x. We multiply the powers such that 4 times 2x, it's going to be 8x. So we can say it's 3 to power 8x times, we have 3 times x. This is going to be 3x. So times 3 to power 3x. These are the powers. I'm multiplying powers here over 3. Then we have 2 times x. This is going to be 2x. So 2 power 2x is equals to 3 to power 6. Then remember that when we are multiplying numbers of the same base, we add their powers. So right now we are multiplying 3 to power 8x times 3 to power 3x. Because they have the same bases, that is 3, we add their powers. So it's going to be 3 to power 8x plus 3x, okay, over 3 to power 2x is equals to 3 to power 6. So if you add this, it's going to be 8 plus 8x plus 3x, 8 plus 3, it's going to be 11. So this can be written as 3 to power 11x over 3 to power 2x is equals to 3 to power 6. Then at this point you are dividing the same bases. So when you are dividing the same bases, you subtract their powers. For example, a to power m divided by a to power n, that will be a m minus n. So it's going to be 11x minus 2x. I've subtracted the powers because we are dividing the same base, is equals to 3 to power 6. So this is going to be 3. Then when you subtract 2 from 11 minus 2, it's going to be 9. So 3 to power 9x is equals to 3 to power 6. Then if the bases are the same, you can equate the powers. So 9x is equals to 6. For you to find the value of x, because that is what the question is after, we divide both sides by 9. So x is equals to 6 over 9. But this is not simplified, so you can simplify by dividing the numerator and the denominator by 3. By 3 it will be 2. By 3 it's going to be 3. So your x is 2 over 3. That is your answer. Thank you guys for watching that short video. Be ready for the next question. The first one was on rules of indices. I'm going to make another video on how you can express your indices to be in form of a quadratic equation. Then I'm going to make another video on the logarithms, how to find them from tables and such things. Don't forget to like the video, subscribe to my channel, and share for us to help people improve on their math skills. Thank you for watching.